Okay, hello. So today we're talking about simplifying radicals. Um, radicals, anything with a radical sign, which usually for us indicates square roots, and we'll talk about that and other irrational numbers along the way here. So first I want to start talking about what's a perfect square. And perfect square, I think we understand that if I ask what are some perfect squares, you might say 4 or 9 or 16. Is there any number that we can, if we square a rational number, that comes out to be a perfect square? So like 3 to the second power, or 3 squared is 9, so 9 is a perfect square. So take a look, and I want you to see if you can write down some perfect square numbers. All right? So you can come back and write some perfect square numbers. All right, so I've come up with a list of some perfect square numbers. Certainly we see 2 squared is 4, 3 squared is 9, 4 squared is 16. So these are the numbers that I would have expected us to come up with, right? These are from our times tables, all the way up through, 11 squared is 121, 12 squared is 144. Did you know 13 squared is 169, 14 squared is 196, 15 squared is 225, 16 squared is 256, 20 squared is 400. Those are numbers that I would think that we would come up with the answers to. But how about perfect square expressions? All right, so I'm talking about maybe something that also would have a variable. So because if we think that, x times x is x squared, oops, so x squared itself has got to be a perfect square. It's the perfect square of x. Because if you multiply x times itself, you get x squared. X squared times x squared would be x to the fourth. So x to the fourth could be a perfect square expression. I listed a couple others down here. So 4x times 4x would be 16x squared. So this 16x squared is a perfect square of 4x. What would 9y to the fourth be the perfect square of? It's 3y squared, right? That's the perfect square of 3y squared, right? And then again, even if something like 12x to the fourth, y to the eighth, z to the 50th, if you multiply that by itself, you get this 144x to the eighth, y to the 16th, z to the 100th. So this is a perfect square expression. It is the perfect square of the 12x to the fourth, y to the eighth, z to the 50th. So I want you to take a moment and just kind of put these into two categories. All right, which of these would you classify as perfect squares and which not? So take a few minutes and see if you can, like 25 is a perfect square, so we'd slide it over here. All right, 3 obviously not. So go ahead and try to see if you can get the rest of these into those two categories. And then pause the video and then come back. Thank you. Okay, how'd you do? 400, perfect square of 20. 4, obviously, right? And then these ones over here are not perfect squares. However, some of them, like 20, 18, even x to the third, they have perfect square factors. 20, one of the factors of 20 is 4, which is a perfect square. One of the factors of 18 is 9, which is a perfect square. One of the factors of x to the third would be x squared, which is a perfect square. So we can't take the square root of these, this group over here. We can take the square root of these over here, right? But some of them we're going to be able to simplify a little bit because there are perfect square factors in them. So the square root of any number n is m, as long as if you square m, you get n back. So if m squared is equal to n, then the square root of n is m. They are opposites of one another, right? The square root of 25 is 5, because 5 squared is 25. And we know that we write square root of 25 like that, right? Square root symbol, square root of 25, that's 5. But we can also use the 1/2 power. And we talked this a little bit about one of those problems that we did in the last chapter, where we had to find the third root, or the cube root of something. We also raised it to the 1/3 power in some of our calculators. So half power is the opposite. It's the same as the square root because it's the opposite of squaring. 5 to the second is 25. The half root of that, if I think back to chapter 4, all right, what happens when you do power to a power? You can multiply the exponents. So this is 5 to the first. 5 squared is 25. If you did 25 to the 1/2 power, you'd be back to 5. All right, so they're the same. So this is the square root sign. 1/2 power means the same thing. All right, and so, these square roots we know already. Square root of 4, square root of 9, square root of 16. All right, these are ones that I would expect that we have no problem. And again, because they're part of our times tables. So thank you to our 3rd or 4th grade teacher who made us kind of memorize those, but we should know these, okay? And like I said, the square root sign is a radical, all right? And the thing that's inside the square root sign, all right, this is called a radicand, all right? If we are solving, let's see, let's retract that. If I write the square root of 49, this symbol means the positive square root of 49, which is 7. Positive square root of 49, that's what this symbol means. However, if it's x squared equals 49, we know from earlier this year that there are 2 answers here. And so if you square root an x squared to get the 2 answers, the square root of x squared is the absolute value of x. All right, the square root of 49 is 7, but since it's absolute value, x is really equal to plus or minus 7. And that's one we have to kind of review, and we'll go over that a few different times here. But the symbol itself means the positive square root of. When you're solving an x squared, when you square root both sides here, the square root of x squared is the absolute value of x. And so that's how we can come up with our 2 possibilities, or 2 answers. All right, now, I said earlier, if we go back a couple, that, and we said that although these ones over here are not perfect squares, 20 has a perfect square factor. 18 had a perfect square factor. And so if we're taking the square root of one of those, we're going to be able to simplify it. And the square root of 8 is similar to that. I don't know what the square root of 8 is. It's irrational, right? But it's not simplified because I can break 8 into 4 times 2, and the square root of 4 times the square root of 2. Well, the square root of 4 actually can be the whole number 2. So this turns into 2 and then root 2. I've got another one. Let's see if I can move it over here so you can see it. Oh yeah, that's the square root of 8. Hey, that's what I just did. I got it right. Let's try this one. All right. Square root of 50, because the square root of 50 has a perfect square in it, 25. All right. Square root of 25 is the whole number 5. Now this other part, the 2, the square root of 2, that's not a perfect square, so that has to stay as a radicand. So this simplifies. The square root of 50 simplifies to be 5 root 2. So if we're going to simplify something, simplify a radical, we're going to take the square root if the radicand is a perfect square. If the radicand is not, we're going to factor the radicand into a perfect square factor times something else. And then we'll square root the perfect square part and leave the rest as the radicand. Okay. So if we look at the square root of x to the third, that's not a perfect square. And hopefully you've come up with the rule at this point is that it's not a perfect square because it's not a even power. But I can break it into the square root of x squared times x because x squared is a perfect square. The square root of x squared is the whole number x, whole variable x. And this last, the third one, or the odd power, has got to stay as a radicand. All right? So we end up with, and, now x to the ninth, square root of x to the ninth. We got to be careful here. Sometimes we may want to say, oh, that's a perfect square because x to the third, because 3 squared is 9. But x to the third times x to the third is x to the sixth, not x to the ninth. So x to the ninth is not a perfect square, but again, the biggest perfect square factor that's in there, I could break up x to the ninth into, I would break it up into x to the eighth times x. And then I can square root the x to the eighth part, which is x to the fourth. And then the last one, the odd or the ninth power, that's got to stay in the radicand. So it's x to the fourth root x. So when we have an odd power, there's always going to, when we simplify, there's always going to be one factor left in the radicand. But we're going to be able to square root by taking half of the power, because remember, it's the 1/2 power. That's what square root means. All right, so see if you can come up with the answer to this. Square root of 25, x to the fourth, y to the sixth. So what we're going to be talking about is it a perfect square? 25 is a perfect square. X to the fourth, y to the sixth, they're all perfect squares, so we can just square root it. And 5 x squared y to the third. But square root of 12x to the fifth y to the seventh, none of these are perfect squares. So if I can't square root them, right, I'm going to break up the 12 into 4 times 3. I'm going to break up the x to the fifth into the x to the fourth and x. And the y to the seventh, I'm going to break it up into y to the sixth times y. Then I'm going to be able to square root all of the perfect square factors. And the things that are not perfect square factors, like 3xy, they're going to remain in the radicand. So it's pretty easy then. I'm going to square root all of the square root of 4 is 2, square root of x to the fourth is x squared. And the square root of y to the sixth is y to the third. And what's left in the radicand is 3xy. Those factors. All right. See if you can do, let's see, these two. I've got 2 problems here. Now let's start with the one up top. Okay. Now, I can square root x squared, even though I can't do 27 or y to the seventh. But I caution you on trying to do that. Don't do it in pieces. In other words, I can't square root the whole thing, so I'm going to break up what I can. 27 is 9 times 3 because 9 is a perfect square. I'm going to leave x squared alone. I don't need to break that up because it is a perfect square. So I didn't take the square root of anything in that step. I just kind of broke it up and do perfect squares times leftovers or not. And now in this next step, I'm going to square root each of these things I just circled. So I get 3 square root of x squared is x, square root of y to the 6 is y to the third. And then what's left over is 3y as the radicand. So I caution you, notice in this first step I didn't break up or square root x to the x squared. It's a perfect square, so I left it alone. I broke up the other parts, 27 and 9 times 3, y to the 7th and then y to the 6 times y. And then, so this is my breakdown step. And then this is my square root step. A couple more things I want to just quickly talk about. Square root of negative 49. There's no real answer here, because there's no number when I multiply by itself I could get negative 49. When I say no real answer, there is an imaginary answer. Some of us might understand this. The square root of negative 1, all right, when you get to algebra 2, that's the term I, is the imaginary number, the square root of negative 1. Because in order for mathematicians needed to kind of close a loophole, sometimes we need the square root of negatives, square root of negative 1 temporarily within a problem. And so we gave it this name so we can kind of use it, even though there isn't a number that I can square root to get negative 1, not a real number. So the mathematicians made up this imaginary number, and it is useful. So you could say that this is square root of negative 1 times 49, and you could say that this is 7i. That's not a real number, 7i, but it is a mathematical expression for the square root of negative 49. We're not going to be dealing with this, all right, so you do not need to know this, but that is going to be something for algebra 2. But I want you to do it. So there's not a real answer. Our answer in 7th grade pre-algebra dealing with rational and irrational or real numbers is that this expression, there's no real answer to that. If there is a 2 times the square root of 18, I'm going to simplify the square root of 18. Hopefully we got this down pat now. 9 times 2, the square root of 9 is 3, times the 2 that's already out here. So out here, as whole numbers, we have, yikes, we have 2 times 3, and then root 2, so it becomes 6 root 2. It's not added, it's multiplied, because this is 2 times the square root of 18. So when you bring the 3 out, this is multiplied together, so it becomes 2 times 3, or 6 root 2. I want you to do this one, see if you can come up with the answer to this, and then come back once you have the answer.